This is Biology Unit 6 revision video looking at dealing with microbes. We're dealing with the three main scientists that you need to know about when it comes to microbes and resistance to antibiotic and how it develops. Now, it's not until fairly recently in our history that people have begun to understand about microbes. Not that long ago, people thought that food decayed because moulds would just spontaneously generate on food, and diseases that people would contract were explained as the effects of evil spirits or caused by bad smells, for example. Now, there are three scientists that you need to know about who started to change the understanding of infectious disease, and these are Louis Pasteur, Joseph Lister and Alexander Fleming. So these are photographs of these three scientists. We've got Alexander Fleming, Louis Pasteur and Joseph Lister. And first of all, we will look at the contribution of Louis Pasteur. So first of all, we'll look at... So Louis Pasteur was a French scientist. He was born in 1822, and in the 1860s he proved that decay of food was caused by microorganisms in the air, not by the air itself, which was previously thought. He came up with the theory that by stopping microbes entering the body, you could prevent illness, and this was known as the germ theory. He also developed the technique of pasteurisation and gave his name to it. Now, Joseph Lister was born in 1827, and around 1865, following Pasteur's theories, he discovered why wounds became infected after surgery. He had the idea that microbes were causing wounds to become infected, and he came up with the idea of antiseptics. He used carbolic acid to spray wounds, and this prevented infection because the antiseptic, this carbolic acid, was killing the bacteria in the wound, preventing infection. He also sprayed the instruments he used as a surgeon with carbolic acid, and this killed microbes on the instruments, which reduced the infections. Today, antibiotics are used, especially when it comes to surgery. They will kill bacteria on surfaces and skin, but the antiseptics that are used today are much safer than the acids that Lister used in the 1860s. So in the early 20th century, Alexander Fleming was a scientist working at St Mary's Hospital in London, and he discovered accidentally that a mould that was growing on an agar plate called penicillium produced a chemical that would kill any bacteria around it. This was clear to Fleming because on the agar plate, wherever the fungus grew, there were no bacteria growing around it. It was killed by the chemical that it was producing, which was called penicillin. Now, it was really difficult to make back then, and it wasn't really used until the Second World War in mass. At this point, it was used to treat war wounds, and a few years later, in the 40s, it started to be introduced and mass-produced to the general public. It was the first product that would kill bacteria in this way, the first antibiotic. Now, antibiotics cannot cure all known diseases. There are two situations where they will not work, and we'll look at these now. Antibiotics will only kill bacteria. They don't kill viruses, and this is because viruses do not feed, they do not have cell structure, they do not have the chemical processes that bacteria have. Now, these key processes in the bacteria are what are targeted by antibiotics, such as building of the cell wall or protein synthesis. These antibiotics will prevent these processes from happening. However, viruses do not undergo these processes unless in a host cell, so therefore antibiotics will not work on them. The other way that antibiotics won't work is that bacteria can develop resistance to the antibiotics. This means that the antibiotic will no longer work on them. Now we'll look at how that could happen. So this entire process of bacterial resistance really depends upon natural selection, which you will remember you covered in Biology Unit 2 when you did about Darwin's theory of evolution via natural selection, where you looked at the process looking at the lengths of necks of giraffes. So I'm going to show you now using drawings how this happens. So first of all, we have a population of bacteria. Maybe this is the start of an infection. Now randomly one of them will develop a mutation. Okay, maybe one, maybe a couple. This happens randomly, it's sporadic. That may give them resistance to an antibiotic. So here I've shown that one of the bacteria in our population has had a random mutation and it has allowed it to become resistant to a certain antibiotic. As this infection grows, they will be treated with antibiotics. This will kill the bacteria and will leave the bacteria that are resistant to that antibiotic. The rest of the population of bacteria do not have this mutation, so they will be killed by the antibiotic, so they are not resistant. The bacteria that is resistant to the antibiotic has survived. As we can see here, the rest of them have disappeared, they've died. And as we can see here, the surviving bacteria has reproduced, it's passed on the resistance gene, and eventually the entire population is resistant to that antibiotic. If this was inside a person, then this person would become ill and would need to be treated with another antibiotic that the bacteria was resistant to. That wasn't resistant to, sorry. Now, antibiotic resistance is a very real issue, and doctors are very aware of these problems that can arise as a result of antibiotic resistance. The use of antibiotics has changed quite drastically over the last 20 years. There are two main practices that doctors will now follow. The first one being that doctors will only prescribe antibiotics when it's necessary. So if you go into the doctors and you have a viral infection, then they will not give you antibiotics, because if you take antibiotics for a viral condition, it increases the chance of strains of bacteria becoming resistant within your body, and therefore prevents antibiotic resistant bacteria becoming the most common strain of that type of bacteria. Also, patients should complete the course of antibiotics that they're given. If not, then all the bacteria may not be killed, and resistance could develop in this situation. So if the full course is taken, the microbes will be killed before any resistance can develop.